All right, this tutorial is going to cover the first few problems of the non-calculator portion of the review for the FSA. So this is a question that you're going to have to know how to do for sure. You're definitely going to see this on the test. And you're given you need to find a line that is perpendicular to this line, which is this line right here, that contains this point. Okay, so you're going to be given this formula on the reference sheet. It's the formula for slope-intercept form of a line, and you're going to use it twice. So you're going to use it here to find the final answer, and then you're going to use it here to solve for B. So we're looking for two things for this answer. We're looking for the slope and the y-intercept of the line, and we're going to see which one matches up over here. Now, I've already worked this out, but I'm just going to kind of walk you through this. And so the way that you would do this is first you need to look, make sure you understand what perpendicular lines, what kind of type of slope that they have. So you look at the original line, which is this, and the slope is 4, so you have to be able to identify that that's the slope. I've got it written right here. And so we need the negative reciprocal of the slope, okay? And you're going to write down m, x, and y because we're going to use m, x, and y to figure out what b is, okay? So the negative reciprocal of 4 over 1 is negative 1 over 4, so we can go ahead and write in this negative 1 over 4x right there. So we already know off the bat that these two it's going to be one of these two answers, okay? And so then we just plug in. So we got negative 1 over 4, we've got our x is negative 8, and our y is 3, and we just plug in y, m, and x right here. So 3, negative 1 over 4, and negative 8, and we solve for b. And it's just an algebra problem from there. We end up getting 1 equals b, and so 1 goes right there, so the answer is C. Okay. Number 2, I'm just going to look for which edges are parallel to AD. Okay, so that's AD right there, and you're going to select all of the ones, okay, that are going to be parallel to AD. Okay, so there'll be multiple answers there. I'm going to skip number 3. Don't worry about that one. All right, so number 4. Okay, which shape is formed by a vertical plane intersecting the cone below? So you need to think about what vertical means. So a vertical plane is going to just cut this, basically. Just imagine a plane going right down the center there. And what kind of shape is going to be formed? Think about it. Right there, that should be pretty easy. What kind of shape is going to be formed if there, and you basically can see what kind of shape is going to be formed right there. Okay. Number 5, what's the coordinate for point M? So that ST is partitioned in a 1:2 ratio. Okay, so this is going to be 3 sections. So let's see, we got 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so it's going to be 3 sections. So you would divide this into 3 sections. So it's 3, and there's 9 numbers. So 9 divided by 3. So there's going to be 3 numbers a section. So 1. Right there. So we got 3 sections right there, and we're going to put the point where ST is going to be 1 on one side of the point, and 2. There's going to be 2 parts on the other side. So it's going to be. So you're going to put the point right where you really have 2 places to choose from, there or there. And considering only one of those 2 are on this number right there, you can really just pick it out by choosing which one is on here. So negative 1 is your option, and 2 is your option. So look right here and see if negative 1 or 2 is here. And if only one of those 2 numbers is here, you can just go ahead and select it. Okay? All right, number 6. Okay, this is going to be a trigonometry function. Okay, so just remember for trig, and any trig problems that are going to be on the non-calculator portion aren't going to actually involve you solving it. It's just going to actually have you setting up the formula to solve it. So this one should be pretty easy. Okay, so remember the very first thing that we do is label our sides. We're going off of this angle. Very first side we always label as the hypotenuse, and then we come around the angle that's adjacent and that's opposite. Okay, so we've got this labeled and that labeled, so we'll erase that one. So we've got O and H. So which one over here involves O and H? So it's going to be sine. So we know the answer's got to be either this one or this one off the bat. And actually we see 42 here, so we know that can't be the answer. Okay, so that one should be pretty obvious there. Okay. Number 7. So it says we've got a box candy container with a square base. So we've got a square prism here, and then we've got a pyramid. It's a square pyramid for the base. So it says how many square inches of cardboard are needed to make the box. Okay, so the first thing we need to do, so it's just asking us, so the square inches of cardboard. So cardboard is going to be on the outside, so this is going to be an area problem. So we're going to find the area of this and this one. So let's see. We're basically going to need to find the area of all 6 sides here. So of this pier, let's call this the cube. Okay, and then pyramid. All right, so we're going to find all 6 sides. So we've got here, we got 4 by 4, we got 4 by 3, and 4 by 3, and we got 2 of those. Okay, because see, we got 4 by 3, 4 by 3. This is going to be 4 by 4, but actually we don't have the top right here. So this is actually, let's do this. So this one, we're going to have 1, the front, the left, the back, and the right, and then the bottom. So let's do it like this. And it doesn't matter really how you organize this. Let's just call this the left side, the back, the right side, the front, the bottom. Okay. Okay, so the front, or the left, is going to be 4 by 3. The back is going to be 3 by 4. The right is going to be 3 by 4. The front is going to be 4 by 3. And the bottom is going to be 4 by 4. And we would just multiply each of those, 12, 12, 12, 12, and 16, add them up. So 12 times 4 is 48, plus 16 is, that's 64. Okay, so 64 for the bottom, okay? And now we just need to do looks like we've got, what, 4 triangles, okay? So and they're all gonna be the same. I believe they're gonna be the same, let me see. Yes, because that's 4, 4, 4, and 4, yes, because that's 3, okay? So the triangles are all gonna be, so you got 4 triangles, are all gonna be the same. Of 4, that's the height, and then the base at 4 times 4 divided by 2. So that's going to be 16 divided by 2. So each of those is going to be 8. 8 times 4 is 32, and this should add up. 64 plus 32, one of those right there. Okay. So a problem like this, you're going to have to find the area of each face and then add them up. All right, number 8. Triangle ABC is reflected with the close line M. Which statement is true? Okay, so you're just going to go through here and pick out all the statements that are true. Okay, so is AC right here perpendicular to CB? Okay, well, it's perpendicular there, so it's going to be perpendicular over there, right? So is AB congruent to AB? Yep, so we know whenever we reflect something, the figures stay the same size. Angle A, yep, it's going to be preserved there. CB. This one is, so CC equals BB. No, that one's not going to be the same. So it would be ABC for that one. Number 9, dilation maps point BC and D onto BC, D prime respectively. Choose all the true statements. So very similar problem. You're just going to pick out the ones that go through these, which ones that are going to be true. Is CD parallel to CD? We just look and see the slope. 1, 2 over 1, 2. 1, 2, 3, 4 over 1, 2, 3, 4. So it's 2, 2 equal to 4 over 4. If it is, they would be parallel. Scale factor is 1 to 2. Okay, so the initial one is going to be, let's see. This one looks like it's going to be 1, 2, 3, 1. 1, 2, 3, 4, 5, 6 over 1. Yep, looks like the scale factor is going to be 1 to 2. Okay. BC over BC. BC over BC. Yep, that looks correct too. Triangle BCD is similar to BCD. Yep, looks like all those are going to be true. All right, 10. Or 10 and 11, fill in the blank on the proof to show the diagonals of parallel and bisect each other. So you're just going to pick out the answers for this proof. So here, angle 1 is congruent to angle 4. So just remember, whenever I have parallelograms, remember these, what kind of angles these are. 1 is congruent to 4. So that's going to be alternate interior angles. So we're going to look down here, alternate interior angles. That would be that one. Blank B. Okay, AB is congruent to DC, so that says that that's a parallelogram. So a rule of a parallelogram is that opposite sides are congruent. So let's look and see what that says. Opposite sides of parallelogram are congruent. There you go, right there. So down here, the correct choice for blank C. ASA. So let's see, which two triangles are we proving congruent? Let's see if we can figure it out first and then pick it out up here. So it says that AB is parallel to BD. Okay, 1. So we said 1 is congruent to 4. 2 is congruent. All right, so it looks like it's going to be this triangle and that triangle. So ABE and ECD. ABE and ABE. Is it looking for the same order, though? I think it is. So we need to make sure we put it in the right order. So A... it's going to be A, triangle A, B, E is congruent to triangle C, D, E. It's got to be in that order, so it could be EBA and EDC. So let's just see if it's in the right order. Oh, looks like it's that one right there, so we're good. That one right there, so it looks like we're good. All right. 13, correct answer choice for D. Congruent parts, congruent triangles. So what are we trying to prove here? AC and BD bisect. AC is congruent to E. AC and BD bisect. AC and BD bisect each other. So, okay, so if they bisect each other, then that means that if they bisect each other, that's what we're finally proving. That means that this AE is going to be congruent to EC and BE will be congruent to ED. So that's what we're going to look for down here. So let's look for AE is congruent to EC, right there, and BE is congruent to ED. So that would be that one. All right, 14. So let's go ahead and stop here. Oh, this won't upload.